Welcome back to another episode of the Func Prog podcast with me, Christopher, and together, sorry, I say this every time, and still I manage to screw it up. Well, I have a special guest today, Robert Kreuzer from Channable. Hello, Robert, and thank you for coming on the podcast.
Yeah, thank you. Happy to be here.
Yes, happy to have you here. So I'm gonna start by asking you to introduce yourself for the audience. Who are you, Robert?
Yeah, sure. I'm Robert. I'm the co-founder of Channable and the CTO of the company. My background is in computer science, and I've now been doing Channable for a long time, for the last 11 or 12 years, together with my two co-founders, Rob and Stefan. And basically what we do is we build a multi-channel e-commerce platform. So that means our customers are e-commerce merchants that want to sell their products on various price comparison sites and marketplaces like Amazon or other big places. And we connect them, the e-commerce merchants, to all of these online marketing and sales channels and help them drive more business that way.
Okay, so if I understand it correctly, the idea is that you put your product on Channable once, and then it goes out to a bunch of places at the same time. Is that sort of the problem that you're solving, or?
That's the main idea, yeah. Basically, nowadays, if you want to be successful as an e-commerce merchant, you need to be on all the marketplaces. You need to be visible on all the e-commerce comparison sites. You maybe want to advertise on Google Ads or different places, and it's a technical challenge for our customers to be on all of these different places to list their products there, and we automate this part for them. And we also help them when they have sales or orders on these marketplaces to link the orders back to their web shop so they can handle them in an automated way. So we're really a tech company that automates all the complicated data logistics and also the data optimization. That's a big part of what we do, is just optimizing the product data, because the better the quality of your data is, your product data, the better usually your sales will be.
Okay, I get it. So how did Channable come about? What's the origin story?
Yeah, it's interesting because we had another startup before Channable, actually, and that's where Channable was born out of. So we had a company called Site2Mobile, which we founded right out of university. I got to know my two co-founders during university, and we all wanted to do a startup. So we started Site2Mobile, which was a business to optimize your website for mobile devices. So this was 13, 14 years ago, so not everybody yet had mobile optimized websites. And this was, tablets and smartphones just got big. And then we had developed this platform which could automatically take your existing non-optimized website and then translate it into a mobile optimized version, with a nice template that would resize dynamically. And this was the first business we started, and we did that for 2 years. And it was never a really big success. It was also not terrible. We did have some business, but it was always more of a service-based business than a product business. And we always wanted to sell the product and not the service. And that's why we pivoted into doing Channable after 2 years. And the reason we had this idea was that we were working with various online marketing agencies already for Site2Mobile. We had contacts to online marketing agencies in the Netherlands, and they all had this problem where they're like, hey, you already have my data, right? Because we also did this for e-commerce sites, the mobile thing. So they were like, you have this technology to extract all of my product data from my website, right? And then couldn't you just put that into a data feed for us? And we thought about that. We were like, oh, that's actually a very good idea. we should probably do that. We should probably put your data into a data feed for you.
Yeah. I mean, I think that's really interesting, because it feels like a lot of startups go through the same journey. You have something that's it kind of works, sort of, and then when you're embedded inside the market, you sort of notice that, okay, there's this other unserved need that you're suddenly seeing. I remember Pixar, for example. The reason they started making movies was because they were developing this kind of printer that could print digital images to film, for example, and they needed something to demo the printer. So and then they noticed people like the films a lot more than the actual printer. But okay, so that's how Channable got started, like, and then you started seeing more traction than when you pivoted to this.
Yeah, a lot more. That was really noticeable difference. Like with the first business, we were always kind of struggling to find new customers, and was always kind of a slog to find new business. And with Channable, even before we kind of had built the first version of Channable, we went to try to sell it to different online marketing agencies, and that actually worked remarkably well. We had, I think, 4 or 5 launching customers before we had built the product. So there were 4 or 5 agencies that said, oh yeah, we really need a solution for feed management. If you guys are going to build this, we will want to use it.
Okay, that's really cool.
Yeah, that was really good vote of confidence. It gave us a lot of confidence, because it's of course always a scary decision to stop what you're doing and pivot to do something completely different. But that gave us a lot of confidence. So we quickly built like the first version of the product, and we built it very quickly. Like I think less than 6 months or so, we built the first version. Was of course very minimal, but that was exactly the right thing to do. I think it was just very minimal, focused just on generating some feeds and with a nice interface. And that was the start. So from there, we at the beginning we only did feed management, but we then quickly expanded and added marketplace functionality, and added also a year later or so we added Google Ads functionality, and that way over the years we expanded more and more. And now we do the whole multi-channel journey. But at the beginning it was just feeds.
Okay, cool. So you even have like ads packaged into this as well, or how does that work?
Yeah, correct. So basically, after we had built the feeds, and I think next we built the first marketplace connections, because we realized, we import all the entire product catalog for our customers. So it's all of their product data, all of their products with their prices, descriptions, titles, everything. So it's very, very valuable information for an e-commerce merchant. And we realized having this data, we can actually sell additional modules or additional services to customers. And first we realized, well, next to generating feeds, we can also integrate with marketplaces with their APIs to push the data directly. So the difference between feeds and APIs is with feed, you just generate a file, we host the file on files.channable.com, and then a price comparison site downloads that link on a daily basis. So that's a pull-based model, and with marketplace it's usually push-based model, where they have an API and you can actually push the product data whenever you want. You can push the latest product data there. So that was the second module we launched. And the third one was ads, where we realized actually people also want to advertise their products, and a lot of people want to advertise on Google Ads. So that's why we built a Google Ads integration. And we have done a whole campaign builder around it, where people can, tailor exactly which customers they want to target, or which keywords they want to target. And then they can say, I only want to advertise my Nike shoes, and I only want to advertise them in this or that country. So it allows them to be very targeted in who they want to target their product ads at.
Yeah. I mean, I'm quite familiar with that problem. I used to work in Google Ads as well, and I know that if you're especially if you're have a lot of different SKUs, it's very annoying to have to sort of add them all to create campaigns, etc. You really want that to be automated,
right? Yeah.
But I mean, back when you started Channable, it wasn't written in Haskell, right? As far as I understand, or
that's correct. Yeah. No, in the beginning we did Python. We still do a lot of Python, and we only added Haskell after maybe 2 or 3 years after we started. So at the beginning it was all Python only on the back end, mainly because my co-founder Stefan and I both knew Python very well, and then that was our shared language. I mean, I also liked Haskell, but Stefan wasn't much into Haskell, so it was more logical that we would just do Python because we both knew it.
Do you use the typing extensions now?
Yeah, we use them heavily. So exactly. So there's MyPy, which is an optional type checker for Python, and we require it for all of our Python code. And we even went so far as to add it to all of our legacy Python code. So I think now probably 7% of our Python code base is probably typed by now. But that was a huge effort to add that typing retroactively.
Yeah, I can understand that. So I mean, sometimes you even though Python is not that crazy of a language, you sometimes use the liberties that you get with completely dynamic typing to do
Yeah.
things that could be hard. But do you think that gives you a lot of leverage now? Like, do you get a lot of use out of the optional, like the type hints?
I think so. Yeah. I think it just serves as good documentation, and it also kind of forces you to write code that can be typed, right? Like in Python, you can do a lot of dynamic stuff, but then you couldn't properly type it anymore. Then the type would always be any to any or something like that. So it wouldn't be so useful. So we encourage people to write code that is well typed, and that they also create, expressive types. Even in Python, you don't have ADTs, but you can create your own classes, etc. So you can create more meaningful types, let's say.
Yeah, and the MyPy type system supports union types, right? As far as I remember.
Yeah, that's correct.
Because I know there's a lot of some Python coders. They are not fans of the type annotations. They prefer the dynamic types. But you seem to have I don't know. For you, it seems to be worth the effort.
Yeah, I think it's definitely worth it. And I think by now, also within the company, I think everybody's kind of on board with this. I think it wasn't that big of a discussion. Maybe when we started, maybe some people were questioning it. But honestly, I think by now, everybody's really on board with having typed Python.
Yeah, but okay, so can you tell me a bit about how Haskell made it into the Channable code base?
Yeah, it's a funny story. Yeah. The main reason we started was that we at some point were having performance problems with one of our Python services. We had a job scheduling system that was written in Python, and it used a library that was basically implementing Prolog in Python. It was convenient in a sense because it could do dependency resolution for us, but it was implemented in a somehow inefficient way, and I think it had a lot of overhead. I believe talking to Redis a lot. And at some point, we just reached a point where the service just couldn't scale anymore, and we couldn't optimize anything anymore. And that was the point when we were like, okay, we need to rewrite this, and maybe we need to use a faster language than Python.
And how come you went with Haskell?
Yeah. So the story there is funny because I had two employees that also liked Haskell, and we were talking a lot about Haskell, but we weren't using it. And they had basically the idea to start using Haskell for it. And I was, of course, quickly convinced that that's a good idea. But then I still had to convince my two co-founders that this is a good idea. So that was maybe a bit more difficult. But at the end of the day, I think they didn't care that much. They saw that we had a problem, and I think they trusted that we know what we're doing. And then so they were also convinced quite quickly. And then we just went from there. We just developed a prototype in Haskell. We just explored how that went, and quickly seemed that we could massively improve the performance of that service by rewriting in Haskell, and that's how we started using Haskell.
Yeah. I mean, it feels like if you start off from a system that sort of re-implements Prolog in Python, you have kind of like I can understand that system was slow, but. After you what happened after you rewrote it in Haskell? Did you get the performance improvements you were hoping for, or?
We did, yeah. That system is still in production today. It's probably almost 10 years later, and we of course had to make some upgrades to that system over the years to make it scale, and we're still working on making that system scale even further. But I think that's really a testament to Haskell and also the engineering that went into the system that we're still using it today. So at that point, it solved all of our performance problems, and for many years we didn't have to do any performance work on that system. We just had to add some features for some new services that we were building. But in hindsight, that was actually a great success. This is the oldest Haskell service that we have. It's a service called Job Machine.
Okay. So the Job Machine thing is implemented in Haskell.
Yeah.
But if we step back a second, because we talked about this before we started recording, but you were familiar with Haskell from the beginning, or when you started at Channable, but how did you get to know Haskell?
Yeah, good question. I first got to know Haskell when I was an exchange student in the United States in Oregon at Oregon State University. So I'd always liked computers and started programming in high school and later in university. But I only got to know functional programming in university, and I was following a course at university at OSU in the US because I was at the time actually still a mathematics student. I was doing math, and that's I think why I liked functional programming, because it's more similar.
It makes more sense, I think, to a mathematician.
Exactly, it feels more logical and nicer and cleaner to a mathematician than other programming languages. So I then fell in love with Haskell, and I followed one or two, I think, university courses in the US. Then later I went back to Germany to finish my bachelor's, and then afterwards I decided I wanted to go more into functional programming. And that's why I decided to do a master's program in FP, essentially. Well, the program was called Computing Science, but it was built very much around functional programming here in Utrecht.
Okay. Yeah, because Channable is an Utrecht-based company, right?
Yeah.
Situated in beautiful Holland.
Yes.
But do you have locations elsewhere, or is it like just in Utrecht?
No, we have more locations now. The company has grown a lot over the years. We're now with about 340 people in total.
Oh wow! Okay, yeah.
And so we have a location in the US, in New York. Actually, we have a sales office. Very nice, close to Grand Central. There, it's about 10 people that try to open up the American market for us. We have a small office in Aarhus in Denmark.
Oh, really? Oh, that's not far from where I live.
where are you located?
I'm in Stockholm, but it's just a short, like,
that's
8-hour drive or something.
Yeah, it's just one country over. It's true. No, the reason is that we acquired a small Danish company called Wake Up Data about 2 years ago. Yeah, exactly. And then since then we have the office in Aarhus, and we have a few people sitting in Berlin, where we have a small office. And we have, I think that's it in terms of offices, but we have a few people working remotely from Spain, the UK, and Germany.
I see. Was there anything like particular that made you sort of start to like functional programming, or was it mainly the math thing, or?
No, I think there were some other reasons. So I started out as a C programmer, and I didn't like it all that much. Or let's say my first experience learning C in high school, and I disliked it so much that I stopped again for at least a year or so before picking it up again. And then later in university, I also had a kind of summer job or so doing a bit of C, but it always seemed very tedious to me to write programs in C, because you were so you had to think about so many low-level aspects and bookkeeping. And I remember in high school I was thinking, I don't want to spend my time chasing semicolons. That first gave up on C.
That you were thinking there were like higher pursuits for the human mind than.
I was kind of hoping that there is a more elegant way to write computer programs, and that's what I found with Haskell. I was like a language that let me focus more on the what than on the how, right? That you can more high level describe what you want your program to do, and it also it matched better with how I thought about writing programs, like how to model your program. With Haskell, you can do this very nicely. You can just define, your data types and the interactions, and you model that as functions, and you can maybe have some type classes. But these abstractions you have in Haskell, they spoke much more to me than what you had in C.
And do you think this was because you had this mathematical inclination, or?
Yeah, I think that was certainly part of it. It was also really appealing to me that Haskell made this strict separation between pure and impure code. That was something that intuitively appealed to me, and I was like, yes, this is a good idea, because I like to think in terms of pure functions and all of these side effects everywhere. That's what really makes programs complex.
Yeah, and I mean I can understand the idea that programming language lets you write like x equals x plus 1 as being like, offensive to a mathematician, because it's like, this, I mean, this, I don't know, it feels like when you're so close to the machine, things, it's more, I usually think of it as like, that's more like, step-by-step instructions that you have to feed to the machine, and like, with functional programming, you're sort of thinking at a higher level.
Yeah.
But do you usually start like, do you think a lot in types, or how, like when you model a program, or how does that work?
Yeah. Nowadays, I think in terms of abstractions or so, in terms of what are the important concepts that we need to have in this program, and then once you have that kind of figured out on paper, then I think I would model it as types and be like, okay, do these types capture everything that I want to capture? And then you start playing with that a little bit, and you maybe write a small program to try it out, and then evolve those types a little bit more. But usually over time, right, you evolve these certain abstractions, and then at some point they feel right. And some point you're like, okay, this allows me to express everything that I want to express in a nice way.
So is that like when you sort of feel that you have captured the ideas in your domain or whatever, or?
Yeah. I mean, we write business software, so we also need to always think about the business domain and need to understand the customer's problems, and need to make sure that we understand the problem they have, that then we come up with a solution that would solve this. And then for the solution, we define specific abstractions that where we make sure, okay, this is how we can explain it to the customer. So we need to make sure that the code kind of does the same thing, the models the same thing.
Yeah, that sounds a bit like, domain-driven design almost.
Yeah, I'm not much familiar, but probably it's very similar.
Yeah, or I mean, we had Almir here from Ren in a previous episode, and he talked a bit about this. And I mean, basically the idea is that, for example, like if you have if the rest of the organization has a special name for something, it's like, you should try to mimic that in the code, for example.
Absolutely.
Like that the code should sort of be a reflection of the business processes. It shouldn't be like it's something.
We have made that mistake of not doing that in the past, where you in the code use a different name than what everybody else in the company is using. Super confusing. So that's definitely a mistake. You should always use exactly the same name and the same abstraction that the rest of the business is using.
Yeah. Can you tell me a bit more about that? Was there a specific miscommunication or?
No. For example, we still build one database that uses like an internal name that we coined in the first, 10 seconds of the company, but that isn't meaningful at all anymore. And now every new hire has to learn this, and it just doesn't make any sense anymore. But it's too painful to rename everything, so that's why it's still as it is.
Yeah. Yeah, I think every company has a kind of like a story like this, and I think you phrased it very good. Like, I have this feeling like, I don't know, Channable is probably not like this, but many companies where I have worked at, the first day when you start work, it's sort of like, they sort of give you a list of like, okay, they open up the closet so you can see all the skeletons, like, just like this part is a bit weird, and this part over here is also weird. It's like a lot of those scenes that you make in the beginning, you have to live with for a really long time.
Yeah, that's true. Like, I mean, some architecture choices we made very early on, and some of them are still with us today, even though today they maybe not. We wouldn't make the same ones anymore in hindsight, but you've gotten used to them, and it's let's say the cost is maybe it's not that bad that it is as it is, but so it's not just also not really worth it fixing it. But it's like you say, now everybody has to learn the way it is.
Yeah. No, but I think it's sort of like a universal truth. Like some mistakes are just like, they're just really hard to get rid of. But okay, so what was it called? Like Job Machine? That was the first Haskell system.
Yeah, first Haskell system. It's a job scheduling system that allows us to schedule background jobs. It's basically something we need to do a lot. You think of things like, importing our customers' data, downloading it maybe from their web shop or downloading it from system like Shopify. Then stuff like optimizing their data. So we have a rule system. That's also a big Haskell system. That's our biggest Haskell system in the data processing system that transforms and optimizes all this data. But basically, the job scheduling system spawns bigger jobs. These are actually just Linux processes. The way we wrote it is like any process on Linux can be a job in the system. And it just runs any program. And then it optimizes the data, and then there's maybe another job that pushes the data to Google Cloud Storage. So think of stuff like that, basically.
Okay, so and what is sort of what is the expected output of one of these jobs?
I mean, the output can be anything. Like the job scheduling system doesn't care. It only cares whether the job succeeds or fails. That's the only thing it really tracks. And there's some progress updating mechanism as well. So you can also send some progress updates while you're running the job, and there's an API in the job scheduling system that can take those updates. But the system itself is really very agnostic to what is running. Like I said, it can be any type of Linux process. You just need to supply the command. It'll run it, and then it'll see if the command finished successfully.
Okay, interesting. But okay, but that was the first system, and then what happened next? Like, did it spread?
Yeah, it started spreading from there. So at that point, we were like a two-language, let's say, company, two backend. I mean, frontend is always a JavaScript or nowadays TypeScript, but backend we were like a Python and Haskell job for a very long time, and Haskell started spreading. We started. Then also rewriting another, the data processing system I just mentioned. It's called Shark Machine. That was a rewrite of another system, because actually I forgot to mention at the time we were also still using Scala because
Oh, okay.
Yeah, I should mention that part. Yeah, because Scala we were using for the data processing in the beginning, because we were using Apache Spark, which is this data processing framework which is written in Scala. And the reason we started doing Scala was because of Spark. We wanted to use Spark to process all of the data that we had from our customers, and because interfacing with Spark was the easiest with Scala, we used Scala at the time.
Yeah, I mean, it feels like Scala really had its moment there in, like, when like data processing, like everyone was using Spark, and like Scala for doing this kind of tasks. But you threw that out.
Yeah, we threw out Spark and Scala, both of them, and rewrote it in Haskell. And so the Spark system was called Spark Machine, and that's why the new system is called Shark Machine.
I really like that name, I have to say, Shark Machine.
Thanks.
But was the how come you threw out Scala? Well,
it turned out not to be a good fit for the type of problem that we had. We had basically assumed that we would have giant data sets from our customers that we need to process, and that's what Spark is good at. It's good at processing very, very large data sets that don't fit on a single machine anymore. And it turned out our data sets are just not that big. They easily fit on one machine. Like our average customer data set is actually in the megabytes or hundreds of megabytes.
Oh, okay, yeah.
Our biggest customer is maybe a few gigabytes, maybe a few tens of gigabytes. But anyway, it's so small that we can easily process it on one machine. And when you then can optimize your code to be optimized for high performance on a single machine, it can be much, much faster than having a distributed system that always needs to, cut up every data set into little pieces and distribute them over a whole cluster. And then you have all the overhead of communicating. So at the end, basically, we had just overestimated how big our data sets actually would be in practice.
Okay. Yeah. So basically, you sort of right-sized the solution back to Haskell.
We right-sized the solution, and we also improved upon the architecture. It's just by rewriting it, we could also just specialize much more on or optimize much more on the problem that we actually have, which is a lot of string processing. Like the 99% of the data we process is strings and not numbers or anything else. So we needed to really optimize the solution for string processing, and that's what we designed the new system for.
Okay, I see. But have you looked at other languages besides Haskell? Like when you were talking about this, like doing this like performance-intensive string processing things, like have you considered writing things in Rust, for example?
Yes, yes, we have. Actually, the last 1.5 or 2 years, we actually rewrote the core of our data processing system in Rust. Basically,
Oh, you did? Okay.
we did, because actually this is a very large Haskell system. Shark Machine is a very large Haskell system, and it consists out of several parts. It has like actually kind of compiler and an optimizer and then a runtime system, and we rewrote the runtime system of that system in Rust.
Okay. So what was the result?
Well, performance is better now. It's about 2 to 3 times faster. And another big advantage is that we don't have the garbage collector anymore, because throughput is therefore also quite a bit better, which in our case now translates into significant savings, cloud cost savings. Because the garbage collector in Haskell is stop the world, and if you run on we always run on big machines like 16 or 32 cores, and the garbage collection basically limited the throughput that we can get on these parallel machines. And with Rust, we don't have that bottleneck anymore, so the throughput we get is 2 or 3 times better. So that literally translates into half the amount of servers that we need compared to Haskell.
Yeah, and I mean, I guess at scale, this actually translates to quite big, how can I say, cost savings.
Yeah, correct. So this was another reason to do it was cost savings, and the second one was just better performance for customers, because actually customers use this system interactively. So there's sometimes a human waiting on a result to be there very quickly. And with the new system, we just get better performance for big data sets. For small data sets, it doesn't matter. Then it's instant, regardless of it's whether in the Haskell or Rust, you just get instant results. But if you have somebody with gigabytes of data, it's better if it's faster.
Yeah, and I mean, then of course the customer is happier if it if it feels a bit snappier, finishes quicker.
Exactly.
But did you have any part in this rewrite, or was that?
No, I couldn't hands-on contribute anything, but I was of course involved in the planning and the design a little bit. But we had a small team internally, I think 3-4 people internally who rewrote everything in Rust.
I see. Yeah. Do you have any other languages? So now I'm counting to 3, like Python, Rust, and Haskell. And I don't know, is there any Scala left, or did that just like?
No, Scala died out with Spark Machine. So that was kind of the end of Scala at Channable. We don't really have any more languages. I mean, on the DevOps side, we sometimes have to do a little bit of Go, because basically all of the DevOps tools, open source DevOps tools in the world are written in Go, and sometimes we have to adjust them a little bit, or it's a plugin or so. So there's some minimal amount of Go. That's basically it.
And what did you use on the front end? Was that TypeScript or?
Yeah. Nowadays it's all TypeScript, and there's still a lot of JavaScript from.
So you're not using anything weird or exotic like Elm or PureScript or anything on the?
No, not at all. It's just React. Like back in the day, we used Ember.js, but nowadays it's all in React.
Yeah, I mean React seems to be like the default go-to solution nowadays.
Yeah.
But did you have any other like comparison points between Rust and Haskell? Like, even though you haven't written it yourself, like, was there any other difference that you noticed?
Yeah. So all the engineers really like the tooling in Rust. They say the tooling is super smooth, and I mean, I've played a little bit of Rust, and I agree. I agree. Cargo is very nice. So the packaging is nice. What else? I think we only use it in a few places now, so we have more experience with Haskell, and I think for high level design, kind of people still like Haskell better. I think with Rust you're more forced to think about low level aspects like the border checker and stuff like that. So when you're not basically, when there isn't any reason that you need the best possible performance, and I think so you just write a business an app that solves a business problem, then I think people generally prefer Haskell because it's more high level and lets you more straightforward write the program. But when there is a good reason to use Rust, for example, you do need the best performance, or you do need to have like low level control over the memory layout or so. That's when Rust really shines.
Yeah, and I mean, better tooling is also, I guess, is something that comes up quite often in the when people discuss Rust versus Haskell. I mean, Cargo. I haven't played that much with Rust, but Cargo does seem very nice.
Yeah, Cargo is great, and they have other nice tools like their the Rust language server is more stable than the Haskell language server. I have to say that the Haskell language server has come a long way, and now when you set it up, then usually it works after that. But with Rust, it just works out of the box. You don't have that initial fiddling phase where you need to configure things and figure out why it's not working or so.
Yeah, and I can never remember the Cabal syntax for doing things. I always forget okay, how do I add a dependency, etc. etc. But do you use Cabal or Stack when you?
Nowadays we use Cabal for everything, but we used to use Stack for everything. But maybe 2-3 years ago we switched to Cabal.
Okay, yeah. How come you switched to Cabal?
I think our feeling was that Cabal was developing faster. That Cabal caught up with all the features that Stack had, and then surpassed it. There were specific technical reasons, but I keep forgetting. It probably had something to do with, we also use Nix for our package management. So with Stack, you always have these snapshots, right? Like snapshots of your libraries, and they are updated every few months or so. And I think now we use a hybrid out of Cabal and Nix. And I think basically we have a Nix package snapshot that gives us specific versions of libraries that we're using, but I think it was more flexible. The combination of Nix and Cabal, I believe, was more flexible. So if you, for example, want to override a specific library version, I think it was easier to do in Cabal plus Nix than with Stack.
Okay. And for the listeners who aren't familiar with the distinction between these two, like Cabal and Stack, could you describe them really quick? Like what's the difference?
Yeah, I think the biggest difference is what I just mentioned is the Stack uses snapshots of the entire world where they snapshot all Haskell libraries on Hackage and say, okay, this is a blessed snapshot. And then they tested that everything compiles, that all of those libraries work well together. And Cabal, I'm not sure. I don't think they do that. I think it's more of a rolling model, but I'm a bit unsure. So
Cabal, I think, is just free for all. Like you can just put any dependency, and then it just it just, for better or worse, it just does what it tells you.
Right.
Like I've never actually used Stack, but like you said, it to me it sounds more like sort of like almost like a Linux distro or something. Like you have this. Known packages that are known to work well together, and then you sort of do a freeze of specific versions, like you said, these are the blessed packages, etc.
Yeah, exactly.
Yeah, I mean, I was speaking of tooling and ecosystem and stuff. What would you say, or just Haskell in general? What would you say is the sort of the best thing? What are the best and worst things about using Haskell in production, would you say?
Best thing is it's really very reliable. Like it's really true. Like once you have a working Haskell program, I think the number of bugs is generally lower than, for example, a program written in Python. I think that's something we can empirically say here at Channable. Like, of course, we still have bugs in our Haskell programs, but they just tend to be smaller and much less frequent than with Python. I think that is just because of the stronger type system that just excludes whole classes of bugs that you usually can have. So one thing is fewer bugs. That makes it more reliable, but also Haskell is a very mature language and runs very reliably in production. Like once you've, maybe tested the program a little bit, it usually runs for years, and the only time we need to, do something is when we want to add a feature or when we want to upgrade some packages. So I would say reliability of Haskell programs is great. That's for me the number one thing. And by the way, performance is very good as well. Like people always underestimate this or so. And like I mentioned, the Haskell is within factor 2 or 3 of Rust. So it's actually a very fast language. It's easily 10 times faster than Python on average, I would say.
Yeah. Yeah, I mean, the Haskell compiler can do some really clever optimizations as well, as far as I understand.
Yeah.
Okay, so, or did you have any more pros
Um, it's a lot of fun to write Haskell. It's very nice.
That's good.
It's a very nice language to program in. Yeah, and maybe on the con side, I think you tend to have a lot of libraries doing more or less the same thing sometimes in Haskell, and these libraries usually don't work well together. So,
okay, yeah.
If you have one library that uses effect system A and you used effect system B in your own code, then they will not automatically work together, and you will have to, I don't know, translate between them or so. So that can be a bit of a struggle. Like you also have some more complicated libraries that are more difficult to learn because they use very advanced type system features or so. So I think the learning curve in Haskell is obviously higher, and I think the reward of using all of these advanced features is usually not very big. So there's a tendency to write very academic code in the Haskell world, which I feel for real world programming doesn't add any value.
Okay, so but you sort of value like a simple Haskell at Channable, or?
I agree. Yes, I'm a fan of keeping it pretty simple and sticking to the basics. And of course, we do use some language extensions, etc. But I usually encourage people to keep it fairly simple and only enable language extensions when there's actually a good reason for it, or that there's a justification. I generally say there needs to be a justification for enabling advanced language features.
Just like not because it seemed interesting.
No, just because it's interesting or fun is like not a good reason to make it more complicated.
Yeah. I mean, there is a tendency I've noticed for people to sort of get carried away. Like, they have this, you have a new shiny toy, and then of course you want to play with it. So, but do you have any sort of like list of like blessed language extensions at Channable? Like,
yeah, kind of. There's some standards that we use everywhere, but like very basic stuff like overloaded strings or lambda case or so, those are used pretty much everywhere. But we do also use GADTs in a few places, or I think there's one service that uses type families. We use all of the fancy deriving machinery, to derive the type class instances that you can nowadays do. So yeah, depending on the program you're writing, we usually take advantage of these nice features. Like I said, sometimes they just make your program better or more readable, and then I think it's a good reason to use them.
Yeah, I think actually, like, I think a good rule of thumb is always like, write the simplest program possible, I think. Because, I mean, sometimes you can actually write simpler code by using a more powerful abstraction, if you know what I'm saying.
Right. Yeah. If that's the case, then I'm all for it. Then I'm thinking then it's a very good use. Yeah.
So I don't know. I sort of like that as a rule of thumb. Like, does it make the code easier to understand? Like for example, like you said with GADTs, they're quite powerful. But if you have a piece of code where you sort of where that sort of where GADTs can solve the problem in a nice and clean manner, like, why not use them?
Yeah, I agree.
What about like the other things that people usually mention as potential drawbacks is, for example, the hiring situation. Like, do you find it's hard to find Haskell engineers?
No, actually, it's worked quite well for us to find Haskell people. Actually, it's a bit of a paradox because on the one hand, there are very few people doing Haskell, but on the other hand, we always manage to find people, and I think the reason for that is that we're also one of the few companies that does Haskell. Like in the Netherlands, you only have a handful of companies doing Haskell in production, and there are quite a few people that do like doing Haskell. So anytime we open a Haskell position, we don't get a lot of applications, but usually we get quite a few good applications. So there's a huge difference with Python where we get like 100 applications or 200, but very, very few of those will actually be good. And with Haskell, we get maybe 5 applications, but half of them will be good.
Yeah, it is kind of funny. Like, you don't get. I mean, because I've been working with niche programming languages for most of my professional life, and I recognize what you're saying. Like, you don't get as many resumes as with like a more mainstream programming language, but you have to throw fewer away. Because like, I mean, if you know Haskell, it's usually not something people just, accidentally slip into. Like,
Right.
I mean, people usually have to actively search it out, which is not sort of the case with like .NET or JavaScript or whatever. Like, that could be the first and only language you learn theoretically. But I mean, if you're a Haskell programmer, most likely you sort of found Haskell yourself for some reason.
Yeah, no, that's true. That's true. I think actually one reason that Haskell has worked out very well for us is that Haskellers tend to be very interested in computer science, and there's a good chance that these will just be very good engineers. People are just generally really interested in computing and try to understand the theory behind it, that are maybe programming language theory or something very specific, compiler construction or parsing theory or so. So these tend to be very good engineers. So that's also why it has worked out well for us that we added Haskell as a second language.
Proof that it actually works. You can hire Haskell engineers, but if people want to work at Channable, like I guess they can find you on LinkedIn or.
Yeah, definitely. We're on LinkedIn, but also we have on the website always all the jobs open. We also sometimes advertise in the Haskell newsletter, and we generally always also post in Hacker News the Ask Hiring column that they have once a month. So I think people can find us. We regularly post new Haskell positions. So if anybody's looking, I'm fairly sure that we'll open another one in next month or next time.
And where like I guess you want people to be or you're not like a remote first company, right? Or
That's true. Yeah. We do require people to be here in the Netherlands, in Utrecht, at least 2 days a week. So we don't say you have to live in the Netherlands, but you have to be in the Netherlands at least 2 days a week.
Have to be comfortable, like I don't know, traveling a lot otherwise. But right. I mean, Utrecht it's a very nice place. Like we talked about before the recording. So I mean, and the Netherlands also beautiful. Nice people. And pretty good weather for being Europe. I mean, as a Scandinavian, you have a longer summer, and also the winter is not as harsh. I think
that's true. Yeah. The winters are generally fairly mellow.
Yeah. I mean, so you can move to Utrecht, program Haskell, perfect.
Yeah. No, we actually have hired quite a few people from abroad who have relocated to the Netherlands, and we have a program to help them also a little bit. It's hard finding an apartment here. I'm going to be honest about that. It's very hard to find an apartment in Utrecht. They also have the whole housing crisis going on in the Netherlands. However, we have successfully hired people from abroad, and then they relocate to Utrecht, and we can host them for a month or so. We actually have 2 apartments here that we rent for just this reason, so that people can relocate to the Netherlands, and then they have some time to find a place.
Yeah, that's cool. I mean, because if I remember correctly, Amsterdam is like the most densely populated city in Europe, I think. And extrapolating from that, I guess that there is a lot, like it's kind of tough to get like you said, to find some place to live, but seems like people are managing.
Yeah, in the end they manage. Everybody underestimates, how much effort it's going to take them to find something, but in the end, people always manage to find something, I think.
Yeah, I mean, sounds good. If you keep your eyes open if you want to work with Haskell, and don't mind moving to Utrecht.
Indeed, yes.
But speaking of if we go back to Haskell for a second, do you have any effect system that you use at Channable? Do you have any preferences there, or how do you deal with the dirty outside world?
We use Effectful in 1 or 2 services, I think. So there are some people who are big fans of Effectful, but it's I guess internally a bit mixed opinions. Like in many of our services, we don't use any effect system. So in some of the services, I think it works quite well, where you can clearly model some effects and where you can just have a clear idea of the effects that the system needs to have, and then that it works nicely. But I think internally there's kind of mixed opinions of whether it's useful or not, or adds something or not.
Yeah, I don't know. Effectful seems very nice. I had Hekat on from Scribe a couple of episodes ago, and so we were talking a bit about Effectful. And I mean, I guess it would, like you said, that's another issue where there's a bit of like ecosystem sprawl in the like in Haskell, right? I mean, in Scala land, it seems that people have settled on that. Like, okay, either. I mean, there are a few options there as well, but it seems like it's even more fragmented in Haskell, right?
Yeah, I can't keep track anymore. There's so many systems.
And there are new ones coming. Like there's a new one called Bluefin, I heard, and then there's another one, like new one that's supposed to be like a, I don't know, new and modern alternative to this other one. So like, yeah, I don't know. And then you have to sort of try to make this compatible with each other as well. It sounds a bit difficult.
Yeah, I think that's one of my criticisms from afar of effect systems, that they don't really compose, right? Like either use one or use the other. And if you want to use two, you need to translate between them, I think. I mean, probably possible in theory, but in practice, I think it's tedious.
Yeah. I mean, I guess that's like, open. But I mean, hopefully, it's a few sort of winners, if you want to call it that, will surface in the end.
Yeah, that would be good. Yeah, that'd be good if the community kind of standardizes a little bit, like in general, right? Like we also standardize on a text library or so, and not everybody uses their different text libraries. So it would be good to have the same. I mean, I also understand that people want to try out new effect systems. That's how you get innovation, right? Everybody tries their ideas, but for business applications or general adoption in the market, would be great if there would be some standardization on one kind of framework.
Yeah, I guess another issue is that there's not like really, one big company behind Haskell. Like, I mean, if there was a big corporate, some library with big corporate backing, I don't know, like React with Facebook, for example, it might help make it more standardized.
Yeah, that would help in general. Like, I think it would be great if more companies would be supporting Haskell. I think we are supporting the Haskell Foundation, and there's of course some other companies supporting them. But compared to like more mainstream languages, there's very limited funding. So I think it would be great if more companies would support the Haskell Foundation.
Yeah, and I mean, speaking of other like potential downsides. Something that I haven't experienced personally, because I mostly do my own like hobby projects, etc. But I've heard that for bigger projects, like compile times can be an issue. Have you had any like problems with that, like compiling your, slow build times, etc.?
It's not that big of a problem for us. So we don't have a monorepo for all of our Haskell modules, but they're separate Git repositories, which I think solves that problem for us. But I've heard from other people or other companies that have large monorepos that is a real pain to deal with. In our case, we have some big Haskell services, but because they can still be compiled incrementally, it's actually in day-to-day programming not that big of an issue. And we avoid features like template Haskell, which force you to recompile everything. So we're a bit pragmatic in the features we use, and it's important that we can compile incrementally, and we also set up our workflow, our local workflow, that we can always do that. So even though we use Nix and everything, we set it up in a way that for day-to-day development, you're just dealing with Cabal, and Cabal, of course, has incremental compilation built in. So we just make sure we don't break that workflow.
Okay, that's interesting. Like, is there any other things you can do to make sure that the code is always like easy to like compile incrementally, other than like avoiding template Haskell?
Yeah, a basic thing is the structure of your modules, like that you think about that, how you lay out your modules and how they import from each other. That's a basic thing we do. But other than that, there's no magic tricks or so, I think.
Okay, because I'm not completely, like, I'm not super familiar with how it works, but so Haskell can compile modules incrementally. Is that how it works?
Yeah. It compiles per module and I think creates an object per module.
Because in the Rust world, I know that in Rust you can only compile individual crates incrementally. So then that sort of creates an issue where putting things in a new crate, that's kind of like I don't know, pretty significant change to the code base. But I guess in Haskell it's not that big of a problem then.
Yeah, it's less of a problem. So you can structure, for example, in Cabal, your repos into multiple components. So we do have, for example, one Git repo that contains multiple Haskell services, and then you can in that repo you can also have a library that the Cabal has, I think, a feature for that to designate something as a library, and that library can then be imported into these different services, and the library then usually needs to be compiled only once, right? And then you only have to recompile your application code, which is maybe much less code than the library.
Oh yeah, that's true. Like now that you mention it, like in the Cabal, you have the different libs and stuff. Yeah, I mean that's good to hear. Like one less thing you have to think about when you if you want to run.
Yeah, I also have to say compilation is for us not a big problem, I would say.
So, do you have any advice like to someone who wants their company to adopt Haskell? Like either if you're like in a decision-making position and say like, oh, it would be a good idea to adopt Haskell, or if you're sort of like a low, or you can take the first one. Let's do them one at a time. So like if you are in a position like yourself, like you think, and you're thinking like, oh, it might be a good idea to introduce Haskell to my company. Do you have any advice for doing that?
Yeah, I do. So what I haven't mentioned yet, but it's maybe good to mention, is that we use Haskell mainly for infrastructure software, or what you would call maybe platform services. So these are like core software programs that are used by other product teams. So also our Python teams are our product teams, and they are the primary user of our Haskell services. And so Haskell is very, very good to write these kind of core infrastructure services like a job scheduling system or like a data processing system. These are systems that don't have a lot of external dependencies. So these are very self-contained systems where you can describe the problem basically on a piece of paper. You can, or mathematically if you want, you can just very clearly define the spec of the program, and you can write down performance requirements and etc. So if you have a system like that, I think Haskell is a great choice for these infrastructure services that are then powering maybe some applications running on top of them.
Okay, so really like core applications, so to speak.
Yeah, that's what we are using it for.
Okay, so your advice would be like, if you have a bunch of services like this, maybe those are the ones you should look at if you want to start to like rewrite things in Haskell.
Correct. Yeah.
So, and on the flip side, are the systems where you wouldn't recommend Haskell?
Yeah, so we have to integrate with a lot of external APIs, for example, and these are usually, some JSON REST APIs, and I think Haskell is probably not the best language for this. You can, of course, do it, but these APIs usually don't have very good specs, or the spec is often incomplete or lying, or the data you get back is actually sometimes looking different than what you're expecting. And in Python, you just deal with that. You just go with the flow. Whatever JSON you get back, you accept. And in Haskell, you'd maybe have a type error or so. So when you're dealing with this kind of messy data, I feel like Haskell is maybe not the best language. Oh, and another important advantage of Python is that you can capture very complete stack traces of everything happening. So we use Sentry, the open source error tracking framework. And for Python, you get like amazing tracebacks with all of the data in context, all of the values of all of the variables that were in play then, and you can maybe even replay it, or you can try to reproduce it later. And with Haskell, that's much harder. Like Haskell doesn't have very good stack traces. There's now some support in the language, but it's much less advanced than what you have in Python. So for debugging these kind of problems, I think Python is much better than Haskell.
Yeah. Okay. So if there's a lot of like messy stuff, I mean, I usually think with like, you know, the surface area of any program will always be untyped, right? Because like, you know, the sort of like when you have stuff coming in from the outside, you know, by definition, you cannot type check that. So you have to sort of parse it up and say that, okay, verify that it's like this type. But if the program is like all surface area, it's not much point in using like very strong typing. I mean, it's just a lot of like, you know, I type up my JSON payload that I receive, and then I just like throw it out the other end. It's not
exactly. It's thrown away again.
Like, why did I do this?
Yeah.
Yeah. I mean, I think that's really interesting. Like, there should be a way. I mean, the Clojure people have some really interesting things with this. Like, you know, when you can sort of define like a spec and sort of generate, you know, property-based tests and all kind of like do really advanced things, except that none of it happens everything happens at runtime. I guess that's sort of the trade-off that, like, you know, maybe when you have like this very expressive, I don't know, it just lets you deal with messy data in a quite like reasonable manner, I think.
That sounds interesting. Yeah.
Yeah, I mean, do you use the IPython anything when you develop?
Yeah. People use it a lot. IPython is great for interactively programming or just exploring, or if you want to call an external API from an interactive IPython session to quickly see what kind of JSON you're getting back, for example, then we use that quite a lot. Yeah.
Yeah, I always miss that, like, you know, and I guess the Lisp programmers are gonna laugh at this and like, oh, that's just a poor man's REPL. But I really like IPython, especially like you said, you know, with the stack traces, when you can just enable, you know, if you switch on the debugger, and then, like, you know, if you get an exception, you just like just catch it and, like, you know, look at the stack trace and jump around in the code and sort of like inspect, you know, what went wrong, etc.
Yeah. For interactive programming and exploring, it's super nice.
Yeah. But I mean, GHCI is not that bad either, I think. You know, you can do quite a bit of like interactive programming there.
Yeah. I think also quite a few of our Haskells have a GHCI-based workflow. So some people, they also kind of live in GHCI, and then they will, you know, edit the source code in their editor, but then they will reload it in GHCI and try it out interactively. So that people also do that.
Yeah. Do you guys use? I mean, speaking of tooling, do you use any like AI-assisted coding workflows?
We're exploring it a little bit, but we're not super heavy users yet. So there are some people who like to use, for example, Gemini from Google, and have that integrated in VS Code or in their PyCharm environment. So we encourage people to try it out. But our policy is that, you know, all of your code you need to understand every line of code that you've written, and needs to be reviewed by a human. So we are exploring it, but we're not early adopters, let's say.
Yeah, because I mean, I guess that's an interesting question. I think, like, whether the LLMs are good at writing Haskell or not.
Yeah, I don't think we use it for Haskell at the moment, to be honest. I haven't heard, at least. No, that's not true. Actually, I heard one colleague was using it to debug a Haskell problem. So apparently at least one person I know of had success debugging a Haskell problem with an LLM. Yeah. But most people I know, they use it for Python.
Yeah. I mean, it seems to be very capable at Python. I mean, and it feels like theoretically it should be. I mean, at least in theory, it should be able to write very good Haskell, because, like, I don't know, that's one thing I really enjoy with, like, this pure functional programming is that you sort of don't have to look at that much code to figure out what's going on. I mean, personally, I think that's a pretty big drawback when you look at the complex Python code base. It's like when you have these mutations and things everywhere. Sometimes it's like, and also like this, this deep class hierarchies. You have like mutations going on everywhere. Sometimes it's like super hard to understand. I mean, what is going on?
Yeah, it's true. I think you can write bad code in any language, but in Python it's very easy to do that. But actually, we have kind of policies around that. So we basically tell people please write more pure Python, or let's say be careful when don't mutate stuff in place.
Yeah, is anyone using this? I remember this library for like having like monads and stuff in Python. I think it's called return.
I haven't heard of it.
Okay, yeah, I know. I think it's easy to go overboard on these things as well. Like, Python is Python, and like we talked about earlier, it has its strengths and weaknesses. But I think a common mistake if you're used to like one way of programming is that you try to transplant that way into different.
No, we do have a Python style guide that basically says please write Pythonic code. So it says don't try to write Haskell in Python. That we discourage that. So we recommend people write Pythonic code. So what a typical Python programmer would recognize as Pythonic code.
Yeah, would you say that's an advantage of Python compared to Haskell? That at least it feels like the Python community has a much stronger idea of like what code should look like, whereas in Haskell it's a bit more of a free for all.
Yeah, I really like that in Python. Yeah, that there is a kind of standard style guide that people stick to and that is readable and kind of sensible. And in Haskell, it's indeed a bit more free for all. I think it's a drawback. It makes it harder to read some code.
Yeah. I mean, it's like if the Python code is like well written, you can almost jump into any code base and sort of like feel at home almost, because there's like I guess partially because it's part of the the Python philosophy that things should be there should be one way to do it, but also because it feels like Python has I mean, in the design there is a very how can I say? I mean, it's designed not to let you be too clever, I guess.
Yeah, that's true. That's true. I think in Python, it's generally if you have the style guide, then it's usually fairly easy to read the code. It's like you say, you can jump almost anywhere in our code base, and with a little bit of time, you'll be able to figure out what's going on. It also helps that it has great editor support, and you can just click on the definition of everything and quickly read. Okay, what's this thing? What's this thing? That also helps.
Yeah, but I guess you have your Haskell style guide as well. Yeah, like you mentioned the preferred language extensions, but do you also have any other sort of like make the guidelines even more strict?
We have a code formatter for both Haskell and Python. So in Python we just use Black, I think, or used to use Black, and in Haskell we also use one which I now can't think the name of, and one of the Haskell formatters, which basically we configure it to our style that we like, and we just run that.
But do you also have any other guidelines don't get too clever with with monad transformers, or with I don't know, you can write really obscure code in Haskell if you want to, it feels like.
Yeah, our guideline is just don't do that. Like I mentioned earlier, it's like only use the language extensions which make sense because they actually add something valuable to the program. And it's the same with using advanced features like monad transformers. Nowadays, we for example, we don't really use them anymore. In the beginning, we think we still used them, but we kind of moved away from that. So nowadays, things fairly simple. It's like usually in pure code, it's just I/O, and pure code. Yeah, you can build some abstractions, of course, but try to stick to the basics if possible.
Yeah, I mean, because I think there is a lot of value in predictability and simplicity.
Yeah. Yeah, you also, what I think people always need to think about is like, if somebody joins the company tomorrow, how long it's going to take them to understand this code base? How easy will it be to onboard somebody? And can you onboard a junior on this project or not? That's as a business, really important question.
Yeah. Do you think, have you found that it's harder to onboard engineers in the Haskell code base than the Python one? Or is it like about the same?
I would say it's about the same, actually. I mean, on any project, of course, people will need a month or so or two to understand what's going on and to understand how things work. But it's the same for Haskell and Python. So yeah, I don't think the difference is that big. I think, I mean, in both languages, you will have some very complicated code, and not any junior engineer will be able to understand that. But that's the same between Haskell and Python.
Yeah, I mean, I guess that's a testament that you sort of succeed in writing simple, like, not making things too crazy with the Haskell, like, keeping it
right
straightforward and readable. Like, do you have any other functional programming languages that you like or that you're sort of playing around with?
Right now, I'm maybe playing around a little bit with Rust, which is not technically a functional programming language, but I think they borrowed a lot of the best ideas of functional programming. I mean, traits are great, right? That's basically type classes, and they basically also have ADTs. They structs. So I like Rust, even though it's not technically functional. In university, I liked Prolog. I haven't done that in a long time, but I just like the ideas behind it. I think basically any programming language should have Prolog as a library or so, because it's just at some point, writing any kind of more complex program, you always have some kind of dependency resolver kind of problem where Prolog is just great at.
Yeah. I mean, Prolog is pretty amazing. Like, it's really, everyone should try, like, spend a few weeks trying to learn Prolog. I think it's like, it's really mind bending, I think.
Yeah.
I mean, the idea that you sort of can, I don't know, run programs backwards almost is pretty crazy, I think.
Yeah. Oh, and if I can add one more, I think SQL is also a decent functional programming language. It's maybe not the prettiest one, but it gets the job done.
Oh, you mean? Oh, yeah. I mean, SQL. It's a very relational algebra. That's powerful.
Yeah.
How do you write SQL at Channable? Do you use like raw SQL statements, or do you have some kind of like abstraction on top of that, or?
Yeah, so we generally encourage to stick to fairly plain SQL. So we don't use any what's called abstraction,
like ORMs or.
Yeah, exactly. Thank you. We don't use any ORM. We do use SQL Alchemy in Python, but not that has two levels of abstraction. We don't use the ORM level, but we use the SQL Alchemy core level. So that is you're not literally writing strings and appending strings, but you have like a Python DSL that allows you to build SQL statements. So it's kind of the intermediate layer between a full ORM and plain strings.
Is that part hard to type, or maybe it doesn't have like that many types? It's just like the Haskell. I guess there's.
Yeah, that's I think very basically typed. I don't think it's not really properly typed.
Yeah. Yeah. No, that would be very. There's a very impressive. Like in the beginning, I was gonna include a question about Idris, because I saw that you had like experimented with that at some point, I think.
Yeah. That was one of our programmers knew Idris, and during a hackathon, he built, I think, URL shortener in Idris, and we were actually using that internally for a while. But I think at the moment we're not using it.
Yeah. Maybe it's like not worth introducing another programming language just for the like dependent types. But there is a very cool video by. David Christensen, where he sort of has this demo where he builds like a type safe ORM on top of Idris, like where you can sort of spec up your database as a type, and do like type safe selects, etc. It's really cool. I can link to it in the show notes. But yeah, I mean that's one of those things where like it's very very powerful, but also like the question is like is it useful in practice? Like I don't know. You can also just run the program and check. That's still an option.
Right. Yeah.
Yeah. Like we're near the end of the podcast, I think. But one thing I would like to ask you about as well is, like, would you have done anything different when introducing Haskell at Channable?
Would have done anything different? I would have probably done it earlier, to be honest. Like, I mean, in hindsight, I can now say that it was a mistake to use Spark and to invest quite a lot of time into that. So it would have been smarter to kind of look at the problem that we're having and then analyze that in more detail before saying, okay, let's use this off-the-shelf Apache Spark solution. That was. But of course, at the time, it was very hard to know this. Like now, with hindsight, it's easier to know this. But I think the advice does generalize to basically, when you have a programming problem, really make sure you understand that problem very very well before you decide to build a new system or so, because it can save you so much time to plan a little bit more ahead, understand the problem properly, and then build a specialized solution for that, before rushing into something just because there's a fancy new framework or there's an open source system where you just assume it's gonna save you a lot of time, but actually in hindsight you realize it didn't quite solve the problem you were having.
I see. Yeah, I mean, I guess if you try to solve a problem you don't have, then the solution becomes the problem, kind of.
Right. Yeah.
But would you have written like Channable in Haskell like from the start, or was Python the right decision, you think?
I actually think Python was the right choice, because you also have to look at the team you have, right? And at the beginning, we just were doing Python because that's what we both knew. That made more sense. And then later, I had a team of people that also knew Haskell, and then it made sense to use Haskell, because then I had the people, and they actually liked Haskell more than Python. So it's also about motivation of your team.
Yeah, and I really like that distinction you made previously. Like, when you said that, like, Haskell is really good for writing these like core systems, and then when you're dealing with more with like surface area stuff, it's almost like that functional core imperative shell pattern, I guess.
Right. Yeah, it's true.
Where you have like a bit of like, at some point you do have to interface with the messy outside world. So then maybe it's better to have a language that is, I don't know, that is really good at doing that. And I guess, I mean, Haskell is a tool like any other. I suppose it's not like, no tool is perfect in every situation, right?
Yeah. Yeah, no, I think exactly. Even if Haskell is a very nice language, it's not the right tool for every kind of problem, and that's also how we're applying it now internally. Like now for new systems, we always look at actually, and we're like, okay, this is what we're gonna do. Is Haskell the best choice, or is it Rust, or is it Python? And then we choose that language.
Yeah. I mean, it's I think it's always good to be pragmatic, right? Like, and there's no point in going the other way around either. Like, I want to choose I always want to have a different tool for everything I do, because then it's like, it becomes hard to manage. But yeah, thank you so much for coming on the podcast, Robert.
Yeah, thank you. Happy to be here.
Yes, and where can people find you if they want to sort of like find you on social media, or ask you about Haskell jobs or things like that?
People can find me on LinkedIn. If they search for my name, I'll pop right up.
Yeah, Robert Kreuzer, and Channable is also on all the social media.
Yeah,
I guess.
Channable on all the different socials.
Yes, and you post. You have a jobs site as well, right? Like.
Yeah. If you go to channable.com/jobs, you'll see all of the open positions that we have at the moment.
Okay. Yes. So if you're willing to move to the Netherlands and want to code Haskell, keep your eyes peeled.
Yes.
Yes. And thanks again, Robert. And have a nice weekend.
You too. Thank you.
Yes. Bye.